Today we are doing lesson 14.4, approximating square roots. We are going to start by just looking at the real number system and sorting some of these different numbers into different categories. The real numbers we talked about earlier in the year and sorting them. The smallest box here is natural numbers. Natural numbers are numbers that you use for counting. 1, 2, 3, 4, 5, 6, and so on. Whole numbers that are used to represent things that you're counting. Whole numbers include everything that's a natural number, 1, 2, 3, 4, 5, but also include whole numbers. Also include 0. So 0 is a whole number, and then 1, 2, 3, 4, 5, all of those are going to be natural numbers and whole numbers. A slightly bigger category is integers. Natural numbers and whole numbers are also considered integers. Integers are whole numbers, 1, 2, 3, 4, 5, and 0, and their opposites. So -1, -4, those are all integers. And then getting slightly bigger, rational numbers include all of these things. Integers, whole numbers, natural numbers are all examples of rational numbers, but also include positive and negative decimals and fractions. And for a rational number, in order to be written as a rational number, if it's a decimal, it needs to either end like 0.5 or have a repeating symbol like 0.3 repeating. And that's because a rational number needs to be able to be written as a fraction. It might not look like a fraction, but it needs to have the potential to be written as a fraction. If we have a decimal that goes on forever without any repetitions, that's considered an irrational number. And there's no way to write an irrational number as a fraction. Okay, so on the side here, we're going to sort these various things into categories, kind of talk about where they fall. Okay, so I'm just going to start at the top. Square root of 25 is 5. That's going to be a natural number. 2/5 is a fraction. So the best category for that one is going to be rational numbers. All right. Square root of 16 divided by 2. Square root of 16 is 4. Divided by 2 would be 2. So this one would also be a rational, well, it is a rational number, but it's a natural number. The square root, the negative value of the square root of 18. 18 is not a perfect square, so when you do the square root, you're going to have a decimal that goes on forever without any sort of pattern. So that's actually going to be an irrational number. All right, 5 divided by 0. When we have 0 on the top, the value is 0. And when 0 is on the bottom, that gives us the value of undefined. We looked at that when we did slope. It's NO, no, you can't divide by 0. So this one is actually not a real number. I'm going to put it up here off to the side. It doesn't fall in our category. It's undefined. It's not really a real number. Square root of 60. Square root of 60 is not a perfect square, so that's going to be an irrational number. The square root of -4. Well, you can't have a negative inside a square root because nothing times itself is going to equal a negative number. So this is also an example of a number that is not real, or these are sometimes called imaginary numbers. You can write them, but they don't have any real number meaning. Okay, let's see. The negative value of the square root of 36. Well, the square root of 36 is 6 or -6, and they want the negative value, so that would be negative 36. -6, sorry. So square root of the negative value of the square root of 36 is going to be 6. All right, 0 divided by 7, you can divide by 0, and the value is going to be 0, so that's going to be a whole number. -8 is an integer. Pi is another irrational number. It goes on forever without any repetitions in its pattern, in its decimal. And then the cube root of 27, I know that's 3. 3 times 3 is 9 times 3 is 27. So since this one is 3, it's also going to be a natural number. All right, so let's take a look at our first type of problem. Our first type of problem here says to classify real numbers. We've looked at classifying things like triangles and quadrilaterals before, and classifying math just means to give all of the names that are appropriate for that number. And we are choosing from these names here. Real numbers. We're choosing from rational, integer, whole number, natural, and irrational. If it's irrational, it can't be anything of these. But if you choose something that's, say, a whole number, then it'll be whole and an integer and rational. Okay, so let's see. Square root of 12. 12 is not a perfect square, so that is going to be irrational. All right, let's see. Negative 25/100 repeating. Well, since it has a decimal and it's a repeating decimal, that's going to make it a rational number. All right, the negative value of the square root of 9. 9 is a perfect square. The square root is 3. And the negative value would be negative 3. So that would be an integer because it's a whole number or its opposite. And then it's also rational. All right. 72 divided by 4. So I need to know if 72 is evenly divisible by 4. And if we're not sure, then we can check. So let's see. 4 goes into 7 once. When we subtract, we get 3. Okay, so 32. So 4 goes into 72 18 times. So the value of this is actually 18. Okay, so I'm just going to write that next to it. It equals 18. And 18 is a natural number. You can use it for counting objects. Is a whole number, or natural numbers and 0. It is an integer, because it is a whole number or its opposite. And it is rational. And then pi is going to be irrational. Probably should have written for this one what the value was. I talked about it, but I didn't actually write it out. That negative value of the square root of 9 is negative 3. That's how I knew how to categorize it. All right, let's take a look at our next one. Okay. Classify the real number. I'm going to go ahead and pause for a minute. Go ahead and pause the video and try these 3 on your own. All right, let's see. So for number 1, I have 0.12 and then 1, 2, 2, and then I have 1, 2, 2, 2, 2. I don't have the same digits repeating. It's not like 1, 2, 1, 2, 1, 2 constantly. There's some sort of pattern to it, but it's not a repeating pattern of numbers. So this one is going to be irrational. We can see that that number is going on forever. That's what the ... tells us. But there's no pattern of the numbers repeating. Okay, next one. The square root of 196. The negative value of the square root of 196. Okay, so the square root of 196 is 14. This is going to be the same thing as negative 14. And that is going to be an integer. It is going to be a whole number. Whoops, no, it is not whole number. Sorry. Whole number needs to be positive or 0. It's going to be an integer, and it is also rational. All right. And then for number 3, the cube root of 2. So the cube root of 2, 2 is not a perfect cube. It is not something that can be split into 3 parts that are this number times this number times this number without decimals involved. So because it's not a perfect cube, then that is going to be irrational. And you can look at those charts of perfect cubes and perfect squares to help you with these problems in your homework if you need to. However, you won't be able to use those charts when you get to your test. Okay, so now we are looking at approximating values of square roots. And in this chapter, just as a reminder, we're not using calculators. This is a way to approximate what our value would be without a calculator. Okay, estimate the square root of 71 to the nearest integer and nearest tenth. Okay, so I'm going to start by thinking about numbers that are perfect squares, that are close to 71. So I know that, let's see, 8 times 8 is 64. The square root of 64 is equal to 8. And then the next one, 9 times 9 is 81. The square root of 81 is equal to 9. 71 is going to be in between these. And when I'm estimating to the nearest integer, I need to think about which one it's closest to. So 71 is 7 units away, if I was thinking about it as a whole number. From 64 to 71, that's a difference of 7. From 71 to 81, that's a difference of 10. So it's a little closer to 8, which means that's how it's going to round. So for part A, it's going to round to 8. For part B to the nearest tenth, I have to do some guess and check, and you do need to show your work for this. Okay, if it's going to round to 8, it's going to be something smaller than 8.5. So 71 is pretty close to being in the middle. So I'm going to start with maybe 8.3 or 8.4, and we're going to see what is the closest that we can get to the square root of 71. Okay, so I'm going to start with just 8 3/10, just as a guessing point. I know it's going to be a little closer to 8 than 9. All right, so remember we're going to multiply like it would be if it was 83 times 83, and then we get to our answer, we're going to put two decimals in. 3 times 3 is 9, 3 times 8 is 24. And a placeholder 0, 8 times 3 is 24. So write my 2, write my 4, carry my 2, that is a 4. I'm going to erase it, write it a little neater there. There we go, that's better. Okay, and then 8 times 8 is 64, plus 2 is 66. Okay, 9 plus 0 is 9, 4 plus 4 is 8, 2 plus 6 is 8, and 6 plus 0 is 6. 1, 2 decimals in the problem, 1, 2 decimals in my answer. So 8.3 is equal to the square root of 68.89. Okay, that's pretty close to 71, but it's not the closest that we can do. So let's try 8 4/10 now. Four times 4 is 16. 4 times 8 is 32, plus 1 is 33. Cross that out, placeholder 0. 8 times 4 is 32. 8 times 8 is 64, plus 3 is 67. Okay, 6 plus 0 is 6. 3 plus 2 is 5. 3 plus 7 is 10. 1 plus 6 is 7. 1, 2 decimals, 1, 2 decimals. Okay, there we go. Almost exactly what we are looking for. So to our nearest tenth, it's going to be something a little bit more than that, maybe 8.4 or 1, something like that. But to the nearest tenth, it's going to be closest to 8.4. All right. Okay, go ahead and pause the video and try these next two on your own. Okay, let's check our answers. So for in nearest integer, I need to think about my perfect squares. So I have the square root of 4, which is equal to 2. 2 times 2 is 4. I have the square root of 9, which is equal to 3. 8 is 1 unit away from 9 and 4 units away from 4. So it's going to round to the nearest whole number, nearest integer, at being 3. So part A is going to be 3. 8 is closer to 9 than it is to 4. Okay, now I need to estimate to the nearest tenth. So I know it's not exactly 3, it's a little less. So I'm going to guess maybe 3.8. I've got to do some guessing and checking for part B. All right, so I'm going to start with 3 and 8/10. Let's see how close we can get. 8 times 8 is 64. 8 times 3 is 24, plus 6 is 30. Okay, cross that out, placeholder 0. 3 times 8 is 24. Carry the 2. 3 times 3 is 9, plus 2 is 11. All right, 4 plus 0 is 4. 0 plus 4 is 4. 3 plus 1 is 4. And then bring down my 1. Okay. Oh, look how big my number is. 14.44. I put 3.8. I really should have done 2.8. I was talking about it being a little bit less than 3, and then I did something bigger than 3. That's fine. It's part of the process. I guess something that was really way too big. Let's try 2 and 8/10 this time. That's what I meant to do the first time, a little less than 3. Okay, 8 times 8 is 64. 8 times 2 is 16, plus 6 is 22. Placeholder 0. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. Well, let's add. 4 plus 0 is 4. 2 plus 6 is 8. 2 plus 5 is 7. 2 decimals, 2 decimals. There we go. Very, very close to what my answer is going to be. It's a little bit under. We can double check by going to 2.9. Let's make sure that this is as close as it's going to get. Okay, 9 times 9 is 81. 9 times 2 is 18. Plus another 8 is 26. Cross that out. 0 placeholder. 2 times 9 is 18. 2 times 2 is 4, plus 1 is 5. Let's add. 1 plus 0 is 1. 6 plus 8 is 14. 1 plus 2 is 3, plus 5 is 8. 8.41. Okay, so now we have to think about which one of these is closer to 8. 7 and 84 hundredths. That's 16 hundredths away from 8. This is 41 hundredths away from 8. So 2.8 is going to be my closest to the nearest tenth. All right, let's take a look at number 5, square root of negative 13. Again, I'm looking for those perfect squares to kind of use as some guidance. So let's see, I know the negative value of square root of 9 is going to be negative 3. I know this negative value of the square root of 16 is going to be negative 4. Negative 13 is 4 units away from negative 9. It is 3 units away from negative 16. So it is just barely closer to this square root of negative 16, which is negative 4. So part A to the nearest integer is going to be negative 4. Okay. Now I need something very close to negative 4, but in between negative 4 and negative 3. So I'm going to start with negative 3 and 9/10. And let's see where that gets us. Okay. So let's see. 9 times 9 is 81. 9 times 3 is 27. Plus 8 is going to be 35. Okay. Placeholder 0. 9 times 3 is 27. 3 times 3 is 9. Plus 2 is 11. Okay. 1, 12, 5, 1, and then I need 2 decimals here, 2 decimals here. Okay, so I would get a positive 15.5. 2.21, which is very, very close to 16, but that is not very close to 13. So now I'm going to guess again. Maybe I'll do 3 7/10 this time. Negative 3 7/10 times negative 3 7/10. 7 times 7 is 49. All right, let's see. 7 times 3 is 21, plus 4 is 25. All right, add a placeholder 0, get rid of this. 3 times 7 is 21. 3 times 3 is 9, plus 2 is 11. Okay, 9, 6, 3, 1, 1, 2 decimals, 1, 2 decimals. This one is very close, 13.69. It's a little high, so now I'm going to have to try negative 3 6/10 and see if it's any closer to 13. So let's see, 6 times 6 is 12. 6 times 3 is 18, plus 1 is 19. Placeholder 0. 6 times 3 is 18. 3 times 3 is 9, plus 1 is 10. All right, 2, 17, 2, 1. All right, now we see which one is closest to. Okay, so 12 72 hundredths. If I'm thinking about it being relating to 13, and if it helps, you can write it out. You don't have to do the comparison in your head. This one I'll write out, just as an illustration. Okay, if I'm going to do this, oops, I wrote plus, I meant minus, because I'm finding the difference away from 13. Let's try that again. 0 minus 2 takes me into the negatives. Can't borrow here, so I'm going to borrow from 30. I'm going to make it 29. I'm going to make this 10. So 10 minus 2 is 8. 9 minus 7 is 2. And then I have my decimal, 0, 0. So this number is 28 hundredths away from 13. This number is 69 hundredths more than 13. So to my nearest tenth, it's going to be negative 3 6/10. All right, let's take a look at this next one. Which is greater, the square root of 5 or 2 2/3? So we need to put them into decimal form to compare them. So 2 2/3. 2/3 is a benchmark fraction. I know that one off the top of my head, so I'm not going to do the work for that. But if I needed to, I could do 2 divided by 3 to get that 6/10 repeating. Now I need to estimate the square root of 5, and then I will be able to compare it. So let's see. A square root of 5. I know the square root of 4 equals 2. And I know the square root of 9 equals 3. And 5 is just a little bit more than 4. So maybe to the nearest tenth, 2.2. Let's multiply that and see. We're going to round to the nearest tenth, and then we're going to compare the two numbers. So 2 times 2 is 4. 2 times 2 is 4. Placeholder 0. 2 times 2 is 4. 2 times 2 is 4. 4 plus 0 is 4. 4 plus 4 is 8. 4 plus 0 is 4. 1 2 decimals. 1 2 decimals. That's only about 16 hundredths away. So it's going to be very close to 2.2. Let's see, does it round to 2.2 or 2.3? We got to double check here. Okay, so 3 times 3 is 9. 3 times 2 is 6. Placeholder 0. 3 times 2 is 6. 2 times 2 is 4. 9 plus 0 is 9. 6 plus 6 is 12. 1 plus 4 is 5. Oof, okay, so it's pretty close between these two. It's a little closer to 2.2. So this one is approximately 2.2 to the nearest tenth. This one is 2 6/10 repeating. So 2 2/3 is going to be the larger of the two values. You do have to show your work for how you compared them. If you've got a benchmark fraction here, sure, you can just write down the decimal part. But for this estimating the square root, you really do need to write down your whole process. Okay, let's look at this next one. The radius of a circle with area A is approximately the square root of A divided by 3. The area of a circular mouse pad is 51 square inches. Estimate its radius to the nearest integer. Okay, so here's the formula they're giving us. Radius equals the square root of the area, and here they told us 51 divided by 3. That radical sign acts like parentheses. You have to do what's inside of it first before you find the square root. So off to the side here, I'm going to do that 51 divided by 3 part. 3 goes into 5 once. With 2 left over, I bring down that 1. 3 goes into 21 7 times. Okay, so 7 times 3 is 21. All right, so my radius is going to equal the square root of 17, approximately. We're using 3 here instead of pi. That's why they said approximately. Okay, so square root of 17 to the nearest integer. Well, I know the square root of 16 equals 4. I know the square root of 25 equals 5. 17 is only 1 unit away from 16. It's 8 units away from 25. It's much closer to that. So we're going to round to the nearest integer. It's going to be about 4. And then we need a label because it's a story problem, so inches. All right, let's take a look at this next one. The distance in nautical miles that you can see with a periscope is 1 17/100 times the square root of h, where h is the height of the periscope above the water. Can you see twice as far with a periscope that is 6 feet above the water than with a periscope that is 3 feet above the water? And explain. Okay, so they're asking us to do two different things. They're asking us to do 1.17 times the square root of 6, and then 1.17 times the square root of 3, and then comparing if these things are about twice as much. Okay, but if this one is twice as big as this one. Okay, so we are going to approximate our square roots, and then we're going to see, is the square root of 6 about twice as much? All right, so I'm going to just make up I'm going to make a list. I'm not going to make anything up. I'm going to make a list of some of my perfect squares. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. All right, I'm going to estimate my square root of 6 part first. So 6 is in between 2 and 3. It's 2 units away from 4. It is 3 units away from 3. So it's almost perfectly in the middle, a little closer to 2. So let's figure out what that is. Okay, maybe 2.4. Let's try that as a starting point. 4 times 4 is 16. 4 times 2 is 8 plus 1 is 9. Placeholder 0. 2 times 4 is 8. 2 times 2 is 4. All right, 6 plus 0 is 6. 9 plus 8 is 17. 1 plus 4 is 5. 2 decimals, 2 decimals. That's pretty close to 6. Let's see, if we do 2.5, is that going to be any closer? 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 5 is 6. 2 decimals, 2 decimals. Okay. Holy moly, those are very, very close to being about the same. It is right in between these two. This is 24 hundredths from below 6. This is 25 hundredths above 6. So to the nearest tenth, it's going to be about 2.4. So I'm going to say that that value is about 1.17 times 2.4. Now I actually don't have to multiply this part together, because if I knew, let's just call this 1. 1 times 2.4, or 2 times 2.4, or whatever, if I'm multiplying the same number over here as my first number, that part isn't going to change. What matters is the second part, to see if the second part is bigger. Okay, so now I'm going to do the same process, but I need to estimate for the square root of 3. It's going to be pretty darn close to 2, but just a little bit less. So let's see, I'm going to start with 1.8. Okay, 8 times 8 is 60. Ooh, I almost wrote 16. 64. Eight times 1 is 8. Plus 6 is 14. Cross that out. Add a 0 placeholder. 1 times 8 is 8. 1 times 1 is 1. I'm going to add those together. 4 plus 0 is 4. 4 plus 8 is 12. 1 plus 1 plus 1 is 3. 2 decimals, 3.24. So that is a little bit bigger than the square root of 3. Let's try 1.7, see what's closest. All right, 7 times 7 is 49. 7 times 1 is 7, plus 4 is 11. Placeholder 0. 1 times 7 is 7. 1 times 1 is 1. 9 plus 0 is 9. 1 plus 7 is 8. 1 plus 1 is 2. Oh, okay, that's pretty darn close. This is 24 hundredths above. This is 11 hundredths below. This one's going to be a little bit closer. So it's going to be approximately 1.7. Okay, so now we're almost ready to answer a question, which is, can you see twice as far? So we're really looking at these second parts, and we're seeing, is this twice as far as this? Well, let's see. What is 1.7 times 2? That'll tell us what twice as far is. 2 times 7 is 14. Here I have 2 plus 1 is 3. 1700 times 2 would be 3.4. So I'm going to write no. Square root of 6 is about 2.4. And square root of 3 is approximately 1.7. All right, go ahead and pause the video and try these last 3 problems on your own. All right, let's check our answers. 4 and 1/5. 4 and 1/5. 1/5 is a benchmark decimal, benchmark fraction. I know 1/5 is 2/10, so 4 and 2/10. Now I'm going to estimate the square root of 23. I know it's really close to the square root of 25, which is 5, and it's a little bit less. So let's see, I'm going to estimate with maybe 4.8, 4.9, one of those things. Let's see, 8 times 8 is 64. 8 times 4 is 32, plus 6 is 38. 4 times 8 is 32. 4 times 4 is 16, plus 3 is 19. 4 plus 0 is 4. 8 plus 2 is 10. 1 times 3 is 4, plus 9 is 13. 1 plus 1 is 2. Okay. Really, really super close there. So 23 is approximately 4.8. I see. This number is so close, I don't even really have to guess and check with anything else. So which one is greater? Well, square root of 23 is greater. 4.8 is bigger than 4.2. All right, the negative value of the square root of 2 and the square root of 2. Okay, so let's see. It's going to be in between 1 and 2, a little bit closer to 1. I don't know. Let's guess maybe 1.3. Negative value, 1.3. 3 times 3 is 9. 3 times 1 is 3. Placeholder 0. 1 times 3 is 3. 1 times 1 is 1. When I add, I get 9, 6, 1, 1.69. Not quite enough. Let's check 1.4. Okay. And actually, I know 14 times 14 is 196. So this would be 1.96. So this is going to be approximately equal to negative 1.4. And that is closer to 0 when we're comparing two numbers closer to 0. When I'm comparing with whichever one's closer to 0 is the larger value. Okay, and my explanation here is really my work to support why this one is bigger. Okay, the area of a circular mouse pad is 64 square inches. Estimate its radius to the nearest integer. Okay, so we're going to do the square root of 64 divided by 3. So I have to start by doing 64 divided by 3. Let's see, 3 goes into 6 twice, exactly. 3 goes into 4 once. Okay, so let's see. I'm going to just do a mixed number here, 21 and 1/3. So the square root of 21 and 1/3, which is like 21.3 repeating. That's what I'm trying to estimate. I know it's going to be in between the square root of 16, which is 4, and the square root of 25, which is 5. I know for my work up on this problem, 4.8 is going to give me a 23. It's going to be a little bit less, but actually now that I'm looking at it, I don't need nearest tenth, I just need nearest integer. So 21 and 1/3. That would be about, well, let's just pretend it's 21 for a minute. 21 would be 5 units away from here. 4 units away here. 21 and 1/3 is even a little bit closer to 25. So to the nearest integer, it's going to be about 5 inches.